Okay, welcome to another Orbiter 2010 video, and this video is going to be another installment in my absolute beginner guide. This video in particular is a direct continuation of the previous video that I did where I was showing the basics of how to use sync orbit MFD so that we can actually rendezvous with a target vessel. In the last video, we spent a whole hour going over the whole process, but right before I got to the point of rendezvous, we're here just 105 kilometers out, I quick saved that scenario so that I could come back to this point and just show again the rendezvous process, doing it a little bit differently than we did before. It's the same exact idea, but we're just going to change things a bit. What we can do when we're approaching a vessel, as I mentioned before, we can either point the vessel toward the positive velocity vector and use the retrograde engines to slow ourselves down, which is what we did in the previous example. Another option that we have is to point the vessel at the negative velocity vector and then use the main engines to slow ourselves down. In either way you do it, you're accomplishing the same thing. One reason that you'll want to do it this other way is if you have a craft that doesn't have retro engines. For example, the space shuttle does not have retro engines like the Delta Glider, so you wouldn't have the option of facing the positive velocity vector and slowing yourself down. You just can't do it. And then the other reason would be if you're traveling at an extremely high, if your difference in velocity is extremely high, then your retro engines wouldn't be powerful enough to slow yourself down in time, so you would need to be facing the negative velocity vector and using the main engines, which are much more powerful, and that would allow you to slow down. So we're just gonna do this the other way this time. We're coming up to the ISS, and again the ISS is inside of that box. We can't see it yet because we're too far away, but somewhere inside this box is the ISS. Now the positive velocity vector is here, so that means the negative velocity vector is right behind me, so I need to rotate 180 degrees, just put in a bit of rotation and let the vessel turn around. It'll get there eventually. So I'm just waiting until I see that negative velocity vector come into view. And I saw it, and it's coming around, and here it is. And there we are. And you can see, it has like a minus V, which I guess helps indicate that that's the negative velocity vector. And it tells us here that the difference in velocity is 132 meters per second, and that's the same as what we'll see here. Now, again, we just need to basically know when to start the burn. And since we're facing the negative velocity vector, remember we're using the main engines this time, not the retro engines. So in order to know when to begin the burn, you basically have to do some calculations to determine how long it's going to take to slow yourself down. And I don't want to get into calculations yet, at least not for these absolute beginner guides. I don't think that would appeal to too many people. So we'll take a beginner's approach to this, and the way a beginner would probably do this, at least the way I did a lot of my early days, is just a bit of trial and error, a bit of testing. You can just kind of get a feel, you get a sense that how much time is it taking to travel 1 kilometer. Right now let's count it at 76. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So it's taking us about 8 seconds to travel 1 kilometer. I can just tell, from a little bit of common sense, that I don't need to bring myself down to a zero relative difference in velocity at this point, because I would be 70 kilometers away from the ISS if I did. That's way too far. if I'm going to rendezvous with the ISS, I need to be on top of the ISS. I need to be, within a couple hundred meters of it. I can't bring myself to zero when I'm this far out because I'm just way, way too far away. So just logically, I can tell that it's too early. I need to wait a bit longer. And in fact, I need to wait enough time that I can go ahead and just do a bit of time warp at this point. Let me go down to, say, 20 kilometers out and just kind of get a feel for how things are at that point. So we'll go ahead and warp time forward at 10. Let's even go to 100 just to get there more quickly. And we're going down to about 20 kilometers. And now we're at about 20. So let's count it again, because notice that in the time that we went from 70 kilometers to 20, we've also slowed down. Our difference in velocities changed. It's now 41, whereas before it was 100. So now it's going to take us, instead of 8 seconds to go 1 kilometer, it's going to take us like 24 seconds to go 1 kilometer. So let's get pointed again back to the negative velocity vector just so that we're in the right position. And if we take a look at the outside, we can kind of spin the camera around. The ISS is basically behind us, but we can't see it. It's too far away still. And as a beginner, this is kind of what you want to do. You just get a feel for it. Just, see how much time's passing, how quickly are things moving. We're still 18 kilometers out. It's quite a bit. That's quite a ways. And if we're going to dock with the ISS, we need to be right up next to it. So we don't need to slow down yet. We're only 41 meters a second. And we know that the Delta glider has really, really powerful engines. So it's not going to take much time at all to eliminate this velocity. So let's warp time forward some more. Let's maybe go down to 5 kilometers and see how things look. Okay, we're about 5 kilometers away from the ISS now. Let's go ahead and rotate to the negative velocity vector right here and get a feel. Maybe look outside. We're coming into sunrise now, so maybe we can even see the ISS at this point. It's back there. Okay, so if you're getting nervous, if you're thinking, well, I'm only 3 kilometers out, I'm awfully close, what you can do is a bit of test burn. Just press Control and hold it and tap the plus key a couple times and eliminate some of this velocity. Maybe go down to 30 meters a second. And as we can see, we're eliminating velocity much faster than the distance is coming down. So let's wait, let's get in a little bit closer, and let's always make sure that we're rotated as much as possible to the dead center of the negative velocity vector. And if we want, we can look outside and even just get a feel, externally for how close the thing is. Now we're at 2.5 kilometers. If you start to get nervous again, just press the Control key and hold it, tap the plus key a couple times, and eliminate another 10 meters per second. Okay, now we're 2 kilometers out. We're moving in at 20 meters a second. And we do want to slow down, obviously, because if we don't, we're going to crash right into it. So down to, let's get to about 1 kilometer, and then we'll eliminate the rest of this velocity. Go ahead and get rotated dead center. And here, this also tells us how far away we are if we don't happen to have this up in front of us. So we're 1.5 kilometers. And we can just get a feel, for how long that's taking to count by. It didn't take us very long at all to eliminate, 10 or so meters a second, so we know we've got plenty of time still. If we want it, we can look outside. We can see it approaching us. Okay, we're down to about 1 kilometer, so let's go ahead now and add in enough main engine to bring the difference in velocity down to 0. And there we are, about right there. Okay, and obviously we're done with the sync orbit MFD, so let's just go ahead and power that side off. Now we want to quickly go ahead and rotate so that we can see the ISS. So I'm just going to put in a bit of yaw. That's the number 3 that I'm pressing. And these indicators help me locate the ISS. They're pointing to where it's at, so I just have to follow those. Looks like I need to go down a bit. There we are. And here, once again, we're basically, stopped just a few hundred meters away from the ISS. The last thing that we do is we switch over to translation. And we want to move this positive velocity vector so that it's right, basically over top the ISS for now. That's good enough. We actually eventually want to put it at the docking corridor, but we'll cover that when we get into docking. So there it is, in just a couple clicks of 6 just to get a little bit of forward momentum. And finally rotate the vessel so that we're facing right at it. Okay, so our situation now is that we're 875 meters out from the ISS, and we're closing in on it at close to a half a meter a second. If we press Control H, maybe tap T one time, we can kind of see how we're moving. So I wanted to show that just to show that there are, two basic ways to establish yourself there at the ISS, there at the end. You either face the positive velocity vector and use retrograde engines, or you face the negative velocity vector and you use your main engines. And the reason to do it the other way, the reason to do it the way that I just did, would be, for example, if you're using the space shuttle. The space shuttle does not have retro engines, therefore you don't have the option of facing the positive velocity vector and using retro engines. Whenever I use the Delta Glider or XR2 or basically any other craft, I personally prefer to face the positive velocity vector and use the retrograde engines to slow myself down. That's just how I prefer to do it. But once you're at this point, we're coming into sunrise, so we've got the whole day ahead of us. Here, if we look at Map MFD, that's how we set up our rendezvous so that it would happen just on the day side. So we've got the whole day now to actually close this last little bit of difference and dock with the ISS. But I'll cover docking in a whole separate video. Now, take a sip of water real quick. Now let's exit out of orbiter. And let me bring up the scenario again where I've just finished the plane alignment. And let's go through this whole process one more time, at least one more time. And the reason I like to do this is because I've used this as example before in previous videos. I think of this type of thing as like math equations, like when you're in school and you learn how to do addition, 25 plus 30 or whatever. And you figure that out and you get the answer. And what does the teacher do? The teacher then sends you home with a whole bunch of homework that's basically just the same thing that you did in class, but you've got to go home and do 30 examples. And the reason you do that is because that constant doing it again and again, giving you different examples helps integrate that information, helps you learn it. So I see like other people that show like a tutorial on how to rendezvous, but you only see them do it one time, and when your example doesn't match theirs exactly, then it's a little hard for you to understand exactly what happens. So basically what I prefer to do is to just show the same thing at least 2 or 3 times depending on the complexity. Like when we did the plane alignment, I showed 2 or 3 examples of that because I feel that's good enough. For rendezvous, a couple of examples at the very least we need to see. So we're back here in the same situation that we were when I started the previous video, but we're just going to go through the whole process again. We've already covered the fact that we know how to get into low Earth orbit, and we've already covered the fact that we know how to do the plane alignment. So we really just want to go over the rendezvous, the sync orbit stuff. We've already, let's bring up orbit MFD on this side. And as before, projection, ship, distance readout above the planet. I'm not going to explain that. I feel we understand why we're doing that at this point. And we're going to target the ISS. Now, in looking at my distance here between myself and the ISS, I would say that it's a good idea to get a little bit closer to the ISS before we really start setting things up. But just to do things a little bit differently, let's go ahead and just start setting things up now. So we'll come around to the day-night terminator. Go ahead and move this over here. We're going to wait till our delta glider is over here at this point so that we can establish our apoapsis at sunrise. Let's go ahead and warp time forward to that point. And right about here we're crossing over, so we'll go down to real time. Now we're going to go to prograde because again we're raising the other side of our orbit, so we need to be facing the direction of flight. We need to be facing prograde. So if you want to maybe make a note, call it step 1 of rendezvous. You know, after you've already got your plane aligned, you know, step 1 would be to basically, you know, establish your rendezvous point. And we're going to do that on the sun, you know, when the sun comes up. And we do that by going to the dark side. You know, we cross the day-night terminator. We're just now crossing over into the darkness. So 12 hours from now, we'll be crossing over to light. So here we are here. We want our bubble, this thing, to be over here. And since we have a nice circular orbit, we can do this with just a little bit of translation thrusters. So you can see that bubble moving around. Okay, so step 1 is done. We now have established that this will be our rendezvous point, which will be, you know, roughly right over here. Go ahead and turn prograde off, and we'll bring this stuff back up so we can see the information. Now step 2 is that we need to know what the altitude of the ISS is at that point. So we're going to go ahead and warp time forward until the yellow line crosses that point. Go ahead and press T a couple of times because we're going to go to 100. And then when we get close, obviously we'll come back to 10. And then we'll actually go all the way back down to 0.1 right as we cross that. So back to root 10x, getting very close. And we're there. So down to real time and down to 0.1. The ISS is now crossing this point. And again, if your bubble happens to be somewhere else and this information's in the way, just press mod a couple of times to make sure that you can see where things are at. Now the ISS altitude at this point, pretty similar to what it was before. It's 361.2. So we're going to write that number down, scratch out our old number. So we know that we want our altitude at this point to be 361.2. So we'll go back to real time. And actually we'll go ahead and we'll warp time forward until we're all the way over to our periapsis. Because in order to raise this side of our orbit, we have to be all the way over here. So we're going to watch our PET value till we're down to about 100 seconds out. Okay, we're close to that point. Let's go back to real time. Let's give the autopilot time to do its job. So step 1, we established where the rendezvous was going to happen. Step 2, we found out what the altitude of the ISS was at that point. And here for step 3, if we want to call it that, we're now going to raise our orbit on that side so that it matches the altitude of the ISS. Okay, the ship is basically settled, so we'll go to 10. And we're just going to wait till our PET value's down to, you know, just a few seconds. We're almost there. Okay, we're basically there, so now we'll press Control and plus a couple times and raise our APA. to 361.2. We're getting very close. Kill the engines.
Translation.
And translate the difference. 361.2. There we have it. Okay, so now we'll turn the autopilot off and we'll go on to the next step. The next step for us is going to be sync orbit. So we're going to bring up sync orbit on this side and we're going to target the ISS. And we're going to change the reference to ship's apoapsis. So mod to ship's apoapsis. And we want to change the length of the display here out to its maximum, which is 18. And we can see here that we are going to run the sync orbit thinks the best time when we will be closest together is going to be 8 orbits from now. And the reason it's more, before the last time we did this it was only 2 or 3, and that was because we closed the distance. In the previous example I was closer to the ISS. Notice this time I'm farther out. Notice this V is bigger, whereas before the V was a little, was much small. Well, it was a little bit smaller than this. So because this V is a little bit bigger, we're just farther away from the ISS, so it's going to take a little bit longer to catch up. What we can do, again, we have to adjust our DT min. We can do that coming up here shortly, or we can wait till we're down to just 4 orbits or so. It's really up to you. We'll go ahead and do it on our first pass though. And we're going to change that at our apoapsis. Remember, we don't want to make any changes to this side of our orbit. So in order to change the timing, we don't care what happens to that side of our orbit. So we're going to do any future burns we're going to do at that point. We're coming up to apoapsis here. We're only 500 seconds out. Let's come back to real time for a minute and figure out which way we're going to have to burn. According to this column, we're going to arrive at this point in 43,730 seconds. The ISS is going to arrive at that point in 43,760 seconds. In other words, we're going to get there first, which means we're ahead of the ISS, so we need to add more time to our passage. So we're going to be burning prograde. We're going to put in a little bit of additional velocity to raise this side of our orbit, which will effectively slow us down because we're adding more distance to our orbit. So let's go ahead and get closer to this point. Okay, we're down to a couple hundred seconds. Let's go back to real time and go prograde to give the autopilot time to settle. And a little bit of 10x to get closer to that point. And again, it's okay to leave the autopilot on when you're just doing a few seconds of time warp like this. You just don't want to have autopilots on when you're going around the whole planet several times. So we're about there, getting close. Just get down to the last couple seconds. We're already in translation mode, I can tell. So now go ahead and press 6 and hold it. And you can see that DT min coming down. And now it's going too far, so I'm going to hold down Control and tap 9. And I just want to get that close to 0. There we go. Sometimes you have to actually go back and forth a little bit because even the control thrusters are just a little bit too powerful. So now we're at the point where we're just 7 orbits away. We're 43,230 seconds away from the time to do the rendezvous. So this is a good time to set up our radio communications equipment. Select ComNav, Control I to bring up the object info, go to the vessel, go to the ISS. We want the transponder first, so that's 130, and we want the docking port second. Again, you can use any of these docking ports. So and this is currently highlighted, so SL plus to go to the next one. And again, I prefer docking port 3 because if you go to docking port 1, you're going to dock upside down. I don't like that personally. So 137.20, and we're all set there, so we can close out the object info box. Press select, and we can bring up the docking MFD for now, although we don't really need it yet. We're still several orbits out. In fact, let's go ahead and leave orbit MFD up for now. So now we're all set. You know, it's actually a very straightforward process once you get familiar with it. All we have to do now is just warp time forward for 7 orbits, and we just want to make sure that our DT min doesn't become too perturbed. So let's go ahead and warp time forward. And I'm not even going to worry about the DT min until we're down to at least the 2nd orbit. So if this changes, you know, there it just went from 0.00 to 0.01. I'm not even going to worry about that until the yellow line is all the way up to here. So we can go ahead and go to 1,000 at this point. We don't want to go any more than that. When orbiting the Earth, you can very easily overshoot. So 1,000 is most I would go, and be very careful even at 1,000. Notice the DT min is being perturbed a bit, and actually I believe these permutations get worse at higher time warps, I think. So we're definitely going to want to make a correction. Notice our DT min is now 0.10. That's quite a bit. That's enough that we definitely want to do a correction. But we'll do the correction on the 2nd orbit when the yellow line's on number 2. Okay. So here we are coming around. And as we're coming around to apoapsis this time, we'll do a correction on the DT min. Okay, we're almost there. Let's go back to not quite real time and go prograde. And this time, again, these numbers match exactly. So this difference isn't enough for me to know which way I need to go in terms of, you know, do I need forward translation or do I need reverse translation? I can't tell because these numbers are too close. So all I can do is just guess. But it's okay because we're talking about a very tiny, tiny amount of thrust. So I want to bring the APT down closer to 0. Prograde's on, that's fine. We're just going to do a couple seconds of time warp. Okay, let me see. I think this one's counting down first by just a fraction. I can't tell. Okay, so I'm just going to do 6, and that brought it down. So just now I'm control 6, overshot there. Now we're back to 0.00. Turn prograde off, and now we should be fine. Even if this slips again by, you know, 0.01 or something, it's not going to be a problem. But you can see there, you know, as you go forward, you know, multiple orbits, the more you go forward, the more this is going to be perturbed. So once you get your DT min to 0.00, if you need to go forward that many orbits, know that you're going to have to make another adjustment when you get down to your, you know, last couple of orbits. We're definitely done with orbit MFD at this point, so let's bring up the docking MFD, and let's switch our HUD over to dock, and let's warp time forward for another full orbit. Go to 1,000, and we got to go around one more time. And when we get down to about this point, you know, go back to, you know, we're only 100 kilometers out at this point. Everything's holding well. Okay, let's get rotated.
Rotation.
Turn our ship so that we're looking at where the ISS will appear. And we'll do the retro engines again because we can. And in order to use the retro engines, we have to bring up the 2D cockpit view, press the down arrow to get to the lower panel, and then click here to open the retro doors. And I'll come back to this view. And now I'm just going to go ahead and warp time forward until we're just down to, you know, 5 kilometers or so. Keeping an eye on the relative velocity, keeping an eye on the distance. Let's go to 100 because we still got a little ways to go. Okay, now we're getting pretty close. Let's go down to 10x. Let's go to real time for a moment and get the vessel situated. That should be good enough for now. Go ahead and warp time forward. What you really have to watch here is the relative velocity. If your relative velocity is really, really high for some reason, like 200 or 300 meters per second, then that means you're going to be closing in your distance much quicker, so you're going to have to start this braking burn sooner. But again, you just kind of get a feel for when to do it. And if you're not sure, you can always just go back to real time and just eliminate a few meters. You know, again, just like that. I'm just eliminating a little bit of velocity, but I don't need to eliminate any velocity yet because I'm still 15 kilometers out. Okay, we're down to 4 kilometers, 3 kilometers. All right, let's get rotated. We're going to point the point the vessel straight at the velocity vector, like that. And we're going to get in really close this time. And I don't need this up anymore, really, because I've got that information. I'm 2 kilometers out, and my difference in velocity is 40 meters per second. I've got that. It's the same information that's given to me here. I can see it here and here. So we're 1.7 kilometers from the ISS. 1.5. Make sure we're rotated exactly where we need to be. Okay, we're only 1 kilometer out. And let's go ahead and start our braking. See the VISS, that number's counting down. And just get down to 5 meters or so. Now I want to adjust the velocity vector using translation thrusters. And again, I like to put it, you know, straight on top of the ISS. The velocity vector is where you're actually going. That's the direction of flight. So wherever that thing is pointing, that's where you're actually going to go. And when we do the docking, we'll actually point the velocity vector at the docking corridor.
Rotation.
But for now, we just want to have it right on the ISS. So we'll rotate to the velocity vector. And we still have a difference in velocity of 5 meters a second. We can go ahead and eliminate that.
Translation.
Just by using translation. And also, this doesn't mean anything anymore. You only use sync orbit just to figure this stuff out. Once you've got it all figured out, you don't need it up anymore. So the difference in velocity is now just a half meter, a little more than a half meter. And there we are. We're 500 meters away from the ISS. And we're basically parked right next to it. Again, if I were to warp time forward at 100 or 1,000, we would definitely drift away from the ISS. So you don't want to do that. Just every now and then you'll have to come back and just make subtle adjustments, you know, using your translation thrusters. That will keep you in position. And we are, you know, here right at the day. So we've got the whole day. We've got, I think I said 12 hours, but it's not. It's obviously just 45 minutes because you circle the globe every 90 minutes roughly. So we've got about 45 minutes of real time of daylight in order to actually complete the docking. Okay, so I'm going to say that's good enough for those 2 examples. I kind of think I want to show at least one other sync orbit example where instead of starting below the ISS, we'll start from above the ISS just so we can see how that's done, and maybe even do one where we're half of our orbit is below the ISS and the other half of the orbit's above the ISS. But at least for now, this is going to be, I think, good enough. If you have any questions, obviously, leave them down below. If there's something that needs more clarification, I'll make another video on it. But these 2 videos, I think, cover it pretty well. So in the next video, the very next video at least, we'll get into actually docking. The rendezvous process, I feel, is the hard part as far as learning it. learning how to rendezvous, what we've done here, that's the hard part. The actual docking process, that's where you go from where we're at here, where we're just 500 meters from the ISS, to actually move over to the ISS and dock with it. That's actually, in my opinion, quite easy, and I don't think people will have too much problem with that. But we will cover it in a lot of detail in the next video. If you like this video, go ahead and leave a comment down below. I always appreciate it if you click that like button, and if you do like my videos and you want to continue being notified when new stuff is posted, go ahead and subscribe to my channel and check the description down below. I've got a Facebook page where I post all my videos, and occasionally I put up some pictures and talk about other things space related. So go ahead and check out all that good stuff. I'll see you in the next video. Okay, welcome to another Orbiter 2010 video, and this video is going to be another installment in my absolute beginner guide. This video in particular is a direct continuation of the previous video that I did, where I was showing the basics of how to use sync orbit MFD so that we can actually rendezvous with a target vessel. In the last video, we spent a whole hour going over the whole process, but right before I got to the point of rendezvous, we're here just 105 kilometers out, I quick saved that scenario so that I could come back to this point and just show again the rendezvous process, doing it a little bit differently than we did before. It's the same exact idea, but we're just going to change things a bit. What we can do when we're approaching a vessel, as I mentioned before, we can either point the vessel toward the positive velocity, and again the ISS is inside of that box. We can't see it yet because we're too far away, but somewhere inside this box is the ISS. Now the positive velocity vector is here, so that means the negative velocity vector is right behind me. So I need to rotate 180 degrees, just put in a bit of rotation and let the vessel turn around. It'll get there eventually. So I'm just waiting until I see that negative velocity vector come into view. And I saw it, and it's coming around, and here it is. And there we are. And you can see, it has like a minus v, which I guess helps indicate that that's the negative velocity vector. And it tells us here that the difference in velocity is 132 meters per second, and that's the same as what we'll see here. Now, again, we just need to basically know when to start the burn. And since we're facing the negative velocity vector, remember we're difference in velocity at this point, because I would be 70 kilometers away from the ISS if I did. That's way too far. If I'm going to rendezvous with the ISS, I need to be on top of the ISS. I need to be, within a couple hundred meters of it. I can't bring myself to zero when I'm this far out, because I'm just way too far away. So just logically, I can tell that it's too early. I need to wait a bit longer. And in fact, I need to wait enough time that I can go ahead and just do a bit of time warp at this point. Let me go down to, say, 20 kilometers out and just kind of get a feel for how things are at that point. So we'll go ahead and warp time forward at 10. Let's even go to 100 just to get there more quickly. And we're going down to about 20 kilometers. And now we're at about 20. So let's count it again, because notice that in the time that we went from 70 kilometers to 20, we've also slowed down. Our difference in velocities changed. It's now 41, whereas before it was 100. So now it's going to take us, instead of 8 seconds to go 1 kilometer, it's going to velocity vector and use the retrograde engines to slow ourselves down, which is what we did in the previous example. Another option that we have is to point the vessel at the negative velocity vector and then use the main engines to slow ourselves down. In either way you do it, you're accomplishing the same thing. One reason that you'll want to do it this other way is if you have a craft that doesn't have retro engines. For example, the space shuttle does not have retro engines like the Delta Glider, so you wouldn't have the option of facing the positive velocity vector and slowing yourself down. You just can't do it. And then the other reason would be if you're traveling at an extremely high, if your difference in velocity is extremely high, then your retro engines wouldn't be powerful enough to slow yourself down in time. So you would need to be facing the negative velocity vector and using the main engines, which are much more powerful, and that would allow you to slow down. So we're just gonna do this the other way this time. We're coming up to the ISS using the main engines this time, not the retro engines. So in order to know when to begin the burn, you basically have to do some calculations to determine how long it's going to take to slow yourself down. And I don't want to get into calculations yet, at least not for these, absolute beginner guides. I don't think that would appeal to too many people. So we'll take a beginner's approach to this. And the way a beginner would probably do this, at least the way I did a lot of my early days, is just a bit of trial and error, a bit of testing. You just kind of get a feel, you get a sense that, how much time is it taking to travel 1 kilometer? Right now let's count it at 76. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So it's taking us about 8 seconds to travel 1 kilometer. I can just tell, from a little bit of common sense, that I don't need to bring myself down to a zero relative